Hey everybody, welcome to video number 19. This corresponds to module 19 for business math and calculators. And the topic is ratios and proportions. So we're going to talk a little bit about what a ratio is, how to set up proportions, and also solving problems like word problems that involve proportions. So we'll go through several examples just to illustrate these concepts. With that, I will share my screen and we will get started with example problems. Alrighty, so here we go. We'll start by first looking at setting up ratios based on a given situation. So here's our first sample problem. Okay, what we want to do is we want to take and translate the situation here into ratios. Um, and so what we've got is we've got some M&M candies, and there are 30 green candies and 50 red candies. So we want to set up a ratio that kind of compares these quantities essentially. So there's several ratios that we could potentially write. The first one is we could write the ratio of greens to reds. And again, there's several ways that you can write ratios. We're going to write them in fraction form because that's the most useful way to write them mathematically, so we can actually use them if we're solving problems and things like that. So we write the fraction 30 over 50 and then reduce it down. So the final ratio is 3 to 5 or 3/5 in fraction form. Okay. Now, like I said, this is one ratio. This is the ratio of green to red. We can also flip this over and write the ratio of red to green. And so it just changes the fraction a little bit in the sense that we end up with the reciprocal, or again, like the fraction that's flipped over. So the ratio of red to green is 50 to 30, or that'll reduce down to 5 to 3 or 5/3. Okay, so both of these ratios are dealing with that comparison of the number of the greens to reds or reds to greens. And it just kind of depends on the situation, which ratio you might use if you are actually solving a problem involving this situation. Now, another ratio that's kind of hidden in the problem is you can also compare the ratio of one of the colors in this case to like the total amount. So for example, if I want to write the ratio of the green candies to the total number of candies that are in the bag, if I add up the 30 and the 50, I know that I've got 80 total candies. And so the ratio of green to the total would be 30 to 80, or again, if that reduced down, 3 to 8 or 3/8. So 3/8 of the bag is made up of green candies. There's another ratio I could potentially write in this situation, depending on, like I said, what I might need to do if I'm solving a problem. And then another ratio, then it would be if I want to compare the red to the total amount. So this time, the ratio is 50 to the 80 total candy, so 5/8 or 5 to 8 when all said and done. So the key thing I want you to get out of this example problem is the idea that when you write your ratios, there's several ways that you can set them up depending on, how you want to compare things. You can compare the two groups, the greens and the reds in this case, to each other, but you can also compare one of the groups to the total, if that makes sense for your particular problem. So just be aware that there's lots of different ratios that can be created out of a given situation. And what we'll find when we look at word problems in particular, it's a matter of kind of finding the ratio that fits the context of the problem that you might end up using. So hopefully this kind of just helps illustrate how to set up the ratios themselves based on a given situation. All right, so the next thing I want to talk about is a proportion and do a sample problem that involves solving a proportion. All right, and this problem is just a generic problem, just to practice the process for solving a proportion. Just as a reminder, what a proportion is it is two ratios that are set equal to one another. So basically, it's a situation where you are dealing with two fractions that you know are equivalent. Um, in this situation with a proportion, usually one of the values somewhere in the problem is an unknown, it's a variable. And so that's why we ultimately end up needing to solve the proportion to figure out what that missing value happens to be. All right, now the trick with a proportion is when you go to solve it, what you need to do is what's called cross multiply. Okay, a cool feature of a proportion is that when you multiply in this pattern, when you take the numerator of one fraction times the denominator of the other and vice versa, what should happen in a proportion is those products, sometimes referred to as the cross products, should be equal. If a proportion is in fact a true statement, those cross products are equal to one another. And so that's kind of the premise behind the approach for solving a proportion is cross multiplying. And what that does is when you multiply, in this case, x times 60 and multiply 12 times 75, what you get is a new equation that you can then solve using the procedures that we've talked about in the past. So 60 times x is the 60x that shows up on the left. 12 times 75 is the 900 that shows up on the right. And what we basically have now is a one-step equation that we can solve. And in most proportions, that next step involves division, where we need to divide both sides, in this case, by the 60 in order to figure out what x is equal to. So sometimes sometimes you will hear people say that the process is cross multiply and divide, essentially. So that's what we're going to end up doing. When we divide both sides by 60, we end up with x equals 15. And so if you think about the original problem, what basically happens is if you think about the two fractions, 15 over 12 and 75 over 60, they are equivalent to each other. They can each reduce down to the same thing. So again, we're talking about two ratios, two fractions that are equivalent to each other in the proportion. So there we go. There's our final answer. X is equal to 15, and we are all set. Now again, this problem is just kind of a generic ratio. There's no real context or generic proportion. There's no real context to it. So let's do a problem that actually, has some meaning behind the numbers. All right, so we're gonna solve this word problem. So we're gonna do the ratio of Cubs fans to White Sox fans at a baseball game was 4-1. So for every 4 Cubs fans, there was 1 White Sox fan. And if we know that there are 40,000 fans at the game, how many of them then were Cubs fans? Okay. So what we need to do to solve is our goal is to set up a proportion. Okay. Now again, we know what the ratios are. We were given that initial ratio of 4-1. So we want to try and pick one of the ratios that we can write that matches our situation. In the problem, we know that the total number of fans is 40,000. So it makes sense then to set up a ratio of Cubs fans to the total. So that's why we've got 4/5 as our first ratio for our proportion. All right, so then we continue setting up our proportion. We put in our equal sign, so 4-5. And then on the other side, we're going to set up our second ratio. Since the first part is the ratio that kind of compares the number of fans, the side on the right is essentially going to deal with the actual numbers. And so in this case, we're trying to find out how many of the fans, how many actual number of fans were Cubs fans. And we know that there were 40,000 total fans at the game. So there's where our variable and our other value in the denominator come into play. The key thing to note in this proportion is that when you look at like the numerators, the 4 is related to Cubs fans. The X is related to Cubs fans. They have essentially the same label, and that's a way to kind of know that you've set up your proportion correctly. The same thing goes for the denominator. The 5 is associated with the total number of fans. 40,000 is total number of fans. Again, they have the same label associated with them. Now, once you get the proportion set up, it's just a matter of going through our procedure, which is to cross multiply and then solve the equation. So when I cross multiply, we end up with 5x, 5 times x on one side. 4 times 40,000 is 160,000 on the other side. And then we solve the equation. In this case, again, we divide both sides by 5. And so x equals 32,000. X was associated with the number of Cubs fans. That's what I'm trying to answer in my problem. So my final answer is 32,000 Cubs fans. And we're all set. So again, this problem gives you a situation where you're using a proportion in the context of, solving some type of word problem or some type of realistic sort of situation. All right, so we went through a few sample problems there, again, dealing with ratios and proportions. Hopefully they help provide some clarification about what a ratio is and what a proportion is and how you can use proportions to solve word problems. Let me know if you have any questions or need any help when it comes to particularly to setting up proportions that are built around word problems. Those tend to be the most challenging situations. If you need anything, just let me know. Otherwise, good luck as you work on the homework problems and get ready for the quiz. And thanks again for watching the video, and we'll catch you in the next video.